Hello, online students. This is Mr. Campbell again with day 12 of our Unit 2 lessons. And we can look here, guys. Last week we left off on the important historical figures of the continental drift theory and of the idea that the Earth is made of plates. So let's kind of go over those people again. We need to know those for some of our quiz questions coming up. Just some announcements, guys. We'll have another notebook check and another unit quiz that'll be 15 plus questions this Friday. So be ready and be on the lookout for those coming up. Grades will be updated soon as well online. So hopefully I'm gonna look to maybe do that after school today. Not only that, we've also got a new assignment that'll be up soon for workbook pages, and we currently have a vocab due this Friday. So please get on those and turn those in as soon as you can because the quarter is ending at the end of next week. But moving forward, guys, again, I'm limited on my time, so I'll try to be a little concise. Please pause the video if I do go fast at any point. We should be writing down this Go Blue on page 14. Again, could be on our notebook check on Friday. Number one, what was the contribution of each historical figure? We had Alfred W., Du Toit, Hess, Suess, and Ortelius. Like I've said before, guys, if you just know the last name with what they did, you should be all good to go for those questions on your quiz coming up. 2, what evidence supports continental drift? And 3, why did the scientific community doubt Alfred Wegener's theory at first? So again, I think 2 and 3 we didn't really have time to go over last lesson. So I'm just going to go ahead and we're going to cover it for the Go Blue because I really believe again I believe and the Go Blue is going to be very concise, but I'm going to give you kind of some of the answers that you should put on page 13. So these answers go to 14. When we get to number 2, you can kind of put that on page 13. So let's go over, pause the video, answer those on your own. Let's continue. So what did each person do? Again, you got to know the last name with what they did, right? Alfred W. Wegener, right? He was plate tectonics and Pangea. We went over that in detail on page 13, but you've got to know, again, those were his main ideas. The idea that the continent was made of plates and moved around, and the idea that the continents used to be all together, kind of like you see down here, in one supercontinent called Pangea. Secondly, Du Toit, just know that he was the first to find evidence for Alfred Wegener, right? Du Toit, keep in mind, nobody all of Alfred's life believed him or supported his theory. And it wasn't until after his life when Alfred W., when Du Toit came about, that he was the first person to find evidence for supporting Alfred's theory, which we'll get into a little bit. And then Hess, guys, his idea was seafloor spreading. The idea that the seafloor is spreading, that the idea that the new crust is coming out, it's pulling apart, and when those plates pull apart, the magma, the lava comes out into the water and hardens into new crust, right? So we call that seafloor spreading, evidence that the Earth is made up of plates moving around. Next, we have Suess, the idea that the Earth was then made up of 2 supercontinents shortly after it was one supercontinent in Pangea. And then lastly, guys, Ortelius, super important name here. Just know that he was the map maker, and he came up with the idea that Earth's continents fit together like puzzle pieces, kind of like you see down here, how South America perfectly kind of fits together with Africa and a lot of those other plates. Again, the continents are moving. They were once potentially together. They were once together. His idea, again, was that they fit together like puzzle pieces. Number 2, super important. You're going to have to add some things on page 13 because we didn't get to it the other day. Your 3 lines of evidence for continental drift include fossils, rocks, and climate. Let's go over those in more detail together. So, again, only write down what's highlighted. This is on page 13. Rock evidence, just write what's in yellow, guys, on page 13. Page 13, okay? Well, just like we find similar fossils in faraway continents across the coastlines, we find similar rocks. So it says here when Pangea broke apart, large land masses split. Similar rock types are found on opposite sides of the Atlantic. So we have a similar rock type in Florida versus northern Africa, as you can see, or Saharan Africa, like in countries like Morocco. How could that even be the case? Because those countries are so far apart. It's because they were once together. And then we kind of see some of those patterns here as well in the rock evidence. Secondly, guys, again, write down this. We've already discussed it before, so I'm going to be very brief with it. Similar fossils are found in faraway continents, right? And we know that those fossils could not have swam across the ocean. We had to have those continents once being together. A perfect example of that is the fern fossil Glossopteris down here that we found in abundance in Antarctica of all places, which is a frozen tundra now. There are no plants in Antarctica hardly at all, and we find fern fossils there. Well, probably means that Antarctica used to be a warm place and used to be near the equator. Again, we find the same fern fossils in India, extremely far away from Antarctica today, in Australia and South America, right? Pretty unique stuff there. And then lastly, guys, our last line of evidence is climate evidence. The soil gives evidence of past climates and environments. So if we dig beneath the ice in Antarctica, we can actually find tropical soil, warm climate soil underneath that ice, which is very fascinating and unique for that area, right? Because we know today it's the opposite of tropical today. All right, and then let's get to our third question here. Why did nobody believe Alfred Wegener, right? Well, he was correct in making the claim of continents moving, but nobody could accurately explain why or how the continents move. They couldn't explain why or how they move, okay? So go ahead and make sure those answers, you have those on page 14. We're going to continue on, again, pages 14 through 15. We're going to discuss plate boundaries, again, convergent boundary types. As you see here, again, we're going to make our own version of this on page 17. Again, this is the vocab that's due Friday. You guys have seen that. That's been posted since last week. So let's go ahead and continue. We've got to talk about convergent boundary types. And why not go ahead and let's do a quick practice question. Oh, no. So exit that. We don't want that. I clicked the button on accident. And let's go ahead and do a quick question here. Kind of talked about that. I got 8 minutes, guys. Hopefully I can pull this off. Okay. Let's go ahead and see. This is a good one. Which contributed least to the theory of plate tectonics, Earth's climate, Earth's rotation, fossils, or rocks? Think about it. Pause the video. See what you think. It's going to be B, Earth's rotation. Earth's rotation. We just talked about fit together like puzzle pieces. So let's go ahead and continue, guys. Let's continue to something new, something new. That is old stuff now. That is old stuff. We've got to talk about the plate boundaries. Mr. Campbell, where is our stuff here? All right, so guys, I might go a little faster, but we'll do our best. 6 minutes. Can I pull this off, guys, in 6 minutes? We'll just see. Loading, opening the document. So guys, basically on page 17, we're going to make 3 columns for each boundary type. So I'm going to need you guys to do is, and that's not the exact boundary. That's not the exact thing I want. All right. So for your first, I'm going to make my screen. Well, let's see if I can get this. Okay. So on my first video, I just want you guys to write down on page 14, what are the 3 plate boundaries? What are the 3 plate boundaries? Got to know what they are, and then we'll kind of list them out and write them out. Okay. If we look here, I'm just going to go ahead and load this video really quick. Again, it will be on Edsby, but you will watch it to answer the following questions, right? Today's early release day, so
take a look at the outer surface of our planet. It may look like one solid shell. But according to the theory of plate tectonics, this outer layer, called the lithosphere, is actually broken up in and break Earth's crust.
3 types.
The relative movement of the plates creates 3 types of boundaries. A divergent boundary occurs when 2 plates move away from each other.
Moving away?
On land,
and you'll need to watch all of that to answer all of those. Okay, which ties in what we're learning today. All right. So what I want you guys to do is, and I know it's on the screen, it's not going to look great. I know it's not going to look great because it's going to be like opposite. Okay. You got 3 types of plates. I want you to make 3 columns, 3 categories, and I know you can't read this because it's opposite framing, but title this page Plate Boundaries, and I need you to make the first one divergent boundary. Plates are moving apart, okay? Convergent boundary with your 2 boxes, plates moving together. Here I have lava coming out. Here I have a mountain. And then transform boundaries, I have plates moving side to side horizontally, okay? So go ahead and take a look at that. copy those pictures and the titles. I know you can't read them, but guys, they're already right down here on the screen, okay? So here we have divergent, okay? Here I have convergent, and here I have transform. So go ahead, I'm gonna need you to pause this video and take the time to make those 3 categories. These are called types of plate boundaries. And here's your title, types of plate boundaries. Okay, watch the video. It does explain these. I really want you to watch the video, even though I kind of gave you the answer just now. It is what it is. And you're going to just make each column 3 columns for each of these, as you see in my pictures. Pause the video, make it like the pictures. There's a mountain. Okay, there's a fault line. You'll understand at a later time. Okay, so continuing, here's the same thing. Same thing. This is on page 15, guys. Page 15, not 17. Page 15. You're doing this on page 15. Same thing. Same thing. As you see here, you could copy that instead if you want it. Okay. We had Oreos in class to do these. We'll talk about that another day. Okay. For divergent boundary, guys, we're only going to go through 2 of these. Okay. Plates are moving apart. Plates are moving apart. Okay. 2 plates move apart. What does this create? Okay. You have new crust forming in the middle, because when the plates rip apart, okay, well, what's going to happen? You're going to have magma, molten rock, come out the middle of it. It's going to go out the middle of it. Okay. And that's going to form new crust in the ocean, especially. So what 2 things, again, you need to have a title called divergent boundary. This is page 15, okay? Your description this is on the right side of the sheet, your right side, right? This right here, it's going to go right there on page 15, okay? You just finished your description, and then you're going to write down produces, okay? We get, what does it create? Rift valleys. We get that from continental crust combinations. We'll talk about that another day. And you're going to get mid-ocean ridges, Again, make sure for each of these on page 15, you have the description in yellow and you have the produces in yellow with the drawings, right? I showed you images. I showed you the correct writing on that in the correct way, because it's on my sheet of paper. I know it's backwards, right, from the camera view, okay? So we researched these in class. Here's some more pictures of rift valleys. Just again, these mountains that kind of pulling apart, usually rivers at the bottom. With mid-ocean ridges, you're going to get magma at the bottom, right? And again, this I will show at a later time because of time, guys. But let's go ahead to conclude for today. We'll do our transform boundary tomorrow. Convergent boundaries, again, plates are moving together. And you're going to have plates, one going below the other, okay? And in this situation, crust is destroyed. What does it produce? We're going to get volcanoes. Again, you have the plates bunching up together, okay? Volcanoes, volcano island arcs. And instead of volcano islands, okay, we're going to get volcano mountains. So volcanic mountains in folded ranges. Again, the crust is getting destroyed. One plate's going below another sometimes. And you're just going to get plates bunching up together, building stuff up. Plates bunching up together, building up stuff. The key phrases here, guys, are volcanoes, island arcs, and volcanic mountain ranges. I've got to go, guys. The bell just rang for my next period. Again, updates on stuff. Message me if you have questions. We'll go over transform boundaries tomorrow. This is Mr. Campbell signing out.